Okay, steganography, steganalysis, and cryptanalysis. We're going to talk about what is steganography, some history behind it, tools today that are out, Steganalysis, types of analysis. We'll also go over some ways to detect Steganalysis on files. There are tools that help detect steganography being applied to different files. And then we'll look at some other tools and references before we get to the lab. So steganography comes from the Greek word steganos, meaning covered, and the Greek word graphic, meaning writing. So stego and graph, covered writing is what it technically means. And it's a process of hiding a secret message with an ordinary message. Like when we were kids, I don't know if you're like me, you always like to create little secret codes and secret messages and secret languages. Like say, I'm going to write a message, but the key is you have to take out, or you have to count every word. Every second letter of every word creates a message. And you send it to your friend Johnny, and you guys pass notes back and forth all day. And if they're intercepted, nobody figures out what's on the paper, just gibberish. And so, maybe you did stuff like that. That's basically, simplistically, what steganography is. It's hiding a message within something. Tonight we're going to be hiding data within a picture, but it's still data. It's still a message of some type. Anyone else viewing the message, by the way, would fail to see the encrypted data, like on the one I mentioned when I was younger. Tonight we'll do the one with the picture. When you just look at the picture, you're not going to know that a person's not going to know there's hidden data in there just by looking at it. Greek history. Here's a sentence or paragraph: warning of invasion by scrolling it on a wood underneath a wax tablet. To casual observers, the tablet appeared blank. Both Axis and Allied spies during World War II used it, like invisible inks, using milk, fruit juice, or urine which darkened it when it was heated, and the message would come through. Invisible ink is also a form of steganography. You might have also gotten a Cracker Jack box or some type of cereal thing when you were younger that or maybe now, that you used for invisible ink, which is kind of cool too. They even make invisible paint. In fact, I think here in Rockford they did here recently a paint that when wet, it shows a message. When it's not wet, it doesn't, but when it is wet, it shows like a drawing or whatever the artist drew. U.S. government is concerned about the use of steganography because, as you can imagine, for security purposes. But common use is basically corporate espionage, sharing corporate secrets, whether it be a person getting paid to do it or just doing it out of spite because they did get a raise and they're wanting to push out secrets to somebody to hurt the company. It's possible that terrorist cells may have used them to communicate information. It's rumored about the Al-Qaeda rumor by posting images on the web, downloading it. Terrorists were able to see terrorist cells and maps of different locations. That was proven, by the way, that the different locations. One thing that wasn't proven was the bombs, basically. They did find maps, so there was nothing there. It doesn't mean there wasn't anything there at one point, but when they finally went to look for them, they were gone. And so, using the same steganography program, the terrorist cell could reveal messages with plans of new attacks. And again, just on simple Al-Qaeda websites, they could do this. Just a simple picture of a sunset or a camel or something, and then somebody would download it. A terrorist cell would download it and push it through a program like we're going to use tonight and extract data. And that data could be images, could be documents, it could be executables, it could be movies, whatever it might be that they wanted to deliver, whatever message it wanted to be. It's also good, very good anti-forensics mechanism to mitigate the effectiveness of forensics investigation. And an example I mentioned is Tuesday, I think, like child pornography. And so a lot of folks have been arrested for child pornography, have been found to use that type of technology to hide their traces. And so there is anti-forensics as well that will look at a few apps that help trace and find files on a computer that have been maybe applied steganography to. So modern digital steganography is encrypted, and the one we'll use tonight will be. It inserts the data and hides it using a special algorithm. There's 3 or 4 different algorithms that we can choose from tonight. The most popular one for encryption is Blowfish is a real popular one, 256-bit encryption. And then they have up to one is 1024-bit encryption. And basically what it does is modifies a little bit the file that it's hiding into. And the technique may also simply append the text or the data to a file and disperse throughout the file. Carefully crafted programs can also be applied to encrypt the data and appear normal, like tonight. Be able to hide a text and a bitmap image and be able to appear normal when it's done. So here's an example of a carrier file on the left, carrier file with a message on the right, and you'll notice a hidden message there that's hidden in the one on the right. And so in order to extract it, though, some program is needed to be used to do that. But by just looking at the image, you know, the person wouldn't be able to notice anything going wrong with that image, or you know, anything fishy. So you can do the carrier files can be a bitmap like tonight. It can also be JPEG, GIF, WAV, MP3, and a whole bunch of other different extensions that it could hide data in. Tools, these are just a few. Steganos, S-Tools, Steg Hide, Invisible Secrets, JP Hide, Camouflage, Hiderman, and hundreds of others that are out there that you can find with a simple Google search of, you know, it doesn't take real long to find them. And most of these are open source tools to use, and some of them give you pretty good instructions, some of them aren't so good. These links here, by the way, that you're seeing, this is being recorded, so you don't have to write them down. But these are popular sites. There's a couple, N. Johnson and topology.org. Crypto is a good one as well. Just to give more information on steganography. So how do you identify them? Glad you asked. If something is applied steganography to a file, to hide a file, how do you identify it? So identifying the existence of an image is not extracting it. I want to clarify that first, I guess. Just because you identify something weird about a file or something off doesn't mean you can do anything with it. You just know something's happened to it. Technically, steganography deals with concealment of a message, not the encryption of it. So Steganalysis essentially deals with detection of hidden content. And then how is this meaningful is, you know, you could, if you knew it was happening, maybe put cameras around the area, maybe put screen scraped recordings towards recording the captions of that or activity of a computer, just to name a couple things you could do to kind of see what's going on. By identifying existence of hidden message, we can identify tools also possibly, because all the tools leave some trace of creation. What I mean by that is if you take a picture and edit it in Photoshop, with the right tools, you can look at the file of that Photoshop file when it's saved, that image, and see in the header file the word Photoshop, and generally the version of Photoshop that was used. So that's an example. So programs will generally insert something into a file when they've edited that file. That makes sense? And so also identifying the tool, you can perhaps then take that tool if you can identify it and extract the message. Now granted, you'd have to guess the password or hack the password, but it is possible to do. Not impossible, but possible. It might take a while to do, but you can do it. Common hiding techniques, appending to a file, hiding the unused header portion of a file near the beginning of the file content, an algorithm used to disperse the hidden message, and this one we're going to use tonight, called LSB, the least significant bit, where basically for every byte it replaces one bit on every byte of a picture with file data until it's completely saturated in the image. Methods of detecting: visual detection, meaning visual detection, looking at a picture and going, something's weird about it. But again, you'd have to have the original to figure out, possibly, if it's really that noticeable. Audible detection. This one here is basically you can determine tools that determine if an MPEG or a WAV file has been tampered with. Statistical detection, looking at maybe things like histogram analysis of a file. But really, structural detection, like date stamps of modification. If you're finding out that images on a folder have been modified quite often on a daily basis with different dates each time, and the images haven't changed really, that could be a red flag. So why would people be modifying images on a public folder? And by the way, corporate espionage a lot of times have been on public folders or FTP sites, or just have company pictures or something like that on there. So size differences, time and date differences, contents or modifications, maybe degradation of image quality, if it's an image you're hiding stuff in. And you'll see that tonight when we do the lab. The more data you hide in the picture, the more degraded the image becomes, right? But you do have to pretty much get over the 3/4 of the file size mark before you even see degradation. So, you know, if you put under that, like say half the size of a file that you're hiding data in, probably couldn't even tell. And then the checksum, every file has a checksum of the data within the file, the size of the file, creation of the file. If that's changed, that could be a red flag as well. So categories of detection: anomaly, histogramic analysis, change in file properties, statistical attack, visual, audible, and then pattern, a pattern consistent with the program used. Like for instance, it gives a timestamp, a certain timestamp, it gives a certain header file in the image itself when you open it up. The goal is accuracy, consistency, and minimizing false positives. You're always going to have false positives anytime you're trying to detect things. Like an example, airports have video cameras running all the time, right? People's faces to detect them for terrorist hot list and all the good stuff. Do they detect people sometimes that are wrong? Yes, they do. And they're detained, and then they have to figure out, okay, this isn't the person, but even though they look like the person, right? So that's going to happen in this as well. There's going to be some false positives. So detecting by viewing it, you literally look at the two pictures and go, I can't see anything different. And you're going to see that tonight whenever you hide regular text in your picture. You're going to look at both the original and the modified and go, I really can't tell the difference. Most of you probably won't be able to tell the difference. Kurtosis is basically the degree of flatness or peakness that comes within an image. This would be like a histogram image, like for all your cameras have them. I think even in Windows and Mac both. If you right click on an image, it'll show you a histogram if you look at it in the right folder or right program. Like I'm trying to remember Picasa. Google has a program called Picasa that'll show you a histogram of every image. When I teach digital photography, that's what they use is Picasa to do that. And it shows them. So if you see changes in that, so a histogram analysis we use to possibly identify. Not real easy to do though, because again, you'd have to have the original to determine what if it's changed from the original. But if you had the original, you could definitely do that. But again, you'd have to compare the original histogram with a modified histogram. So that means, again, having to have the original to do that. And a lot of times you're not going to have that in a folder. You're just going to have the original that you think is the original anyway with no modified. Now, what you could do is, I guess, get a backup tape and restore it to a different folder and then compare them, possibly. You could do that as well. But then again, that would be painstaking. I don't know if it would be real worth your time doing. Unless you really, had some hint that this was going on. It's just be a waste of your time. Property types. You can compare properties of files. Like an example here, the time changed for a minute, and name's the same, Looks like the file size has changed a little bit from 240 pixels 759 to 235 pixels 750 pixels. And then the timestamp changed a little bit. You'll also notice the checksum changed as well on both. But again, in order for this to occur, you have to have the original and the modified. File signatures. Every file has a signature of some type, a hexadecimal signature that you could determine some changes that have occurred. But again, it'd be hard to determine what file was used to change those files or what program was used. If you copy the original or the virgin file, the original file, and compare it to the modified, then maybe you could see something different, whether it be visual, whether it be through properties, whether it be through using a hexadecimal, whether it be using the Steganalysis or Histogram. So everything from Notepad could be used to a hex editor to determine that. And then reviewing multiple files may identify a signature pattern on all the files, like maybe in the file it puts in the name of the program or something at the top of the header. Because you can open up a picture within Notepad. Doesn't, just a whole bunch of gobbledygook and, a whole bunch of weird symbols. But at the very top of that image, generally there's something that makes sense. Like the file that was used to create the image, whether it be Photoshop, the timestamp, things of that nature. If that changes, that could be something to watch. So here's a popular analysis program, WinHex. It just shows you the hexadecimal version of all the file contents. Hiderman, this is actually used specifically to hide and unhide files. It's a little different than the one we're going to use tonight, but does the same exact thing. So this one has two things you can do. You can hide files and drop a file on the left side, or you can unhide a file. Hiderman also gives you a bitmap or a hexadecimal viewer of a bitmap, and you can review the differences in a hex file from the modified file. This one here says, viewing the header information at the beginning of the file, we see the bitmap is indicated by the BM file signature. And so there's actually a signature the Hiderman puts in there then, BM, in the header file. But I will say a lot of these programs don't do that. They don't put anything in the header file at all. So it's very difficult, not impossible, to trace what program is used. So when you view the end of the file, comparing it from the original or the virgin file, you can then look at seeing if there's any differences. So here we have the top, which is the original. The bottom is the modified. You'll notice on the bottom right there's a whole bunch of stuff that wasn't on the top right, and also on the hexadecimal. So it's at the same location, BF or 8F73 in the file, and there's something different there. But again, it's just finding it. You're not going to be able to extract anything or do anything. You're just finding something different. In addition, it says note the last three characters, CDN, the bottom right there. And it could be a signature of Hiderman possibly. Hiding different messages in different files with different passwords. We see that the three letters or characters CDN are appended to the end of the file. So evidently Hiderman does that. StegSpy. It's a signature identification program, searches for Stego signatures and determines the program used. So this one actually looks at a file and can determine if it's a popular file, or program anyway, that was used to do it, what program was used to do the Stego. And so this one works pretty good with popular ones, but if it's something that was homegrown, it's not going to recognize it. All right. So notice here it says it identifies 13 different steganography programs. There's literally hundreds, maybe thousands of steganography programs out there. So not a lot, but it's better than nothing, I guess. It'd be interesting if you wanted to, take this lab further at home and see if the lab we do tonight, if this can detect that picture that's been modified, and it can detect the program that was used. So here it gives an example, a pop-up after it scans a picture that says Hiderman's been detected. Again, just because it's been detected doesn't mean anything. It just means it's been detected, and it doesn't mean you can extract it. But you know something's happened to it. And could it be a false positive? Yeah, it could be a false positive, for sure. Spy-hunter.com is where it's been found, but again, they might have changed the URL. This is old. Signature-based Steganalysis used to identify signatures like Invisible Secrets, JP Hyde, Hiderman as well. How is it handy? No original file to compare to. Search for the signature pattern to determine presence of hidden message within the signature. And a signature can reveal a program that was used possibly to hide the message. So a couple more slides. Cryptanalysis is basically Steganography is the goal to hide the message, not encrypt it. Cryptography provides a means to encrypt the message. So the app will be used tonight, hides it and encrypts it both. So knowing the Steganography program used to hide a message can be extremely handy when attempting to reveal the actual message. Identifying cracking it, though, is a whole other issue. Unfortunately, some of these programs use very strong encryption, like 128 or 1024-bit encryption, and good luck on trying to decrypt that. Yeah.
So what programs, I mean, it's not going to be just a group of programs, but are there programs associated with whatever program was used to encrypt or hide the file that is used to extract?
Yeah. Oh, yeah. It's the same one. It's the very same program.
So if you were to if you were to find what program it was, you would also have the way to be able to extract that.
Yeah. You just have to know the password.
Oh, okay.
You have to know the password.
Sure.
Yeah. That's the downside.
Sure.
Yeah.
He said that a lot of these programs have signatures on them. Is that like a program signature or just the way they are written?
Well, like I said earlier, on the header of the image file, when it saves it, it puts something in the header of the image file at the top that you can't see in the image, but if you open up a hex editor or notepad, you can see at the top of it, like say acronym for the program or something.
So what purpose would that serve? I mean, wouldn't that make
it
easier
for
somebody?
It would definitely make it easier, but when the programmer is creating it, whoever the programmer was, he might have originally created, or she might have originally created it just for, non-evil purposes, right? And and was hiding it for, maybe we'll talk about tonight, to secure data or something on a network.
Okay,
and
so
don't
it's
really
not
care if
always
somebody
done
finds
for
out.
a illegal kind
No,
of.
exactly.
Yeah.
So, but I'm not to say though that even if you found it in those, you could even reveal what the password was. It'd be very difficult to do. So, like it says there, practically all Steganography programs use passwords to hide the message and encryption both. So, Cryptanalysis, what it does, and I'll end on this one, even though we have more slides, we're going to go right to the handout. Cryptanalysis identifies a program using to hide a message, identifying the location of the program, signature in the file, identifying the location of the password, identifying the location of a hidden message, and identifying the algorithm used to encrypt it. And all of that can be used to decrypt it if you have the right tools to use. So you can do password guessing, which can take forever depending on the strength of the password and what encryption was used. Knoppix is a CD I do recommend. We used to pass it out in here years ago, but it's still going to be downloaded. Knoppix STD is a version of Linux that has a whole bunch of forensics tools on it, and then just sheer brute force. So let me keep advancing here to the, and I'm going to post, this will all be posted on our lab folder, so even though I'm not going to read all of it. Dun, dun, dun. This one might be important to talk about, forensics. If performing forensics and discovering a potential Steganized file, look for evidence of the Steganography programs on the computer. That'd be wise to do, because generally the person that used it probably has a program on the computer, or they could. If they're really smart, though, they would have it on like a USB drive or something to where it wouldn't be on the computer, but they may have it on a computer. Leverage other OS or application passwords found on the machine. This may also be the password used to hide the message or reveal the message. Look for other hints such as passwords written down on notes, diaries, letters. For more information, see Electronic Crime Scene Investigation, a guide for first responders, U.S. Department of Justice. Here are some alternative detecting routes. LNS, ntsecurity.nu, LADS, haysoft.de, and NTFS ADS check, diamondcs.com.au. They take a file and try to encrypt or decrypt the file and password. So let's go right to the handout. Steganography. Did you guys get to download the image or was it a zip file?
Yeah.
I can't remember. So let's go through the handout real quick, and then we're going to do it. I'll let you go at it. So first, the objective of the lab is to hide an image, hide some data in a bitmap image using Steganography program. It will only work on a Win32 machine, so if you have a 64-bit, well, it should still work on a 64-bit because it's a 32-bit, so you should be fine. It's called Hide in Picture version 2.1. Student prep, you just have to download the zip file, follow directions. Instructor prep, went over that already. Gave you a link to download it. Steganography, art of hidden writing. I just want to mention a couple things in this one. In fact, to blow up this message here. So steganography has been used since ancient Greece, extensively during World War II, and still exists today. Here's a message on February 5th, 2001, USA Today reported the United States had proof that Osama bin Laden and associates were hiding mass photographs of terrorist targets and instructions for terrorist activities and web pages on the internet using stenography techniques. An example of one, which is kind of cool here, this was sent by a German spy in World War II, and here was a message. Apparently, neutrals' protest is thoroughly discounted and ignored. Is man hard hit? Blockade issues affects pretext for embargo on byproducts, ejecting suets and vegetable oils. Means absolutely nothing when you read it. Like, don't care. But if you take the second letter in each word, the following message emerges. Pershing sales from NY June 1st. So we went from that to digitizing steganography by using the software tool we're using today. The one we're using is a freeware tool. There's a lot of paid ones out there. So at the bottom of this page, I think, is where it's kind of hidden there. Verify data file. So when you open that zip file, I'm going to go ahead and stop it. We'll say right here, that one and this one. Okay. And I'll make it a little bit bigger so you can see it. That one and that one. So if we look at the top two digital numbers, the 10-digit numbers, 200 for is good, top and bottom. 53 is okay, top and bottom. 2 change to 3. 195 change to 194. 54 change to 55. 69 same. 191 190. 56 57. Now that's just one byte in the picture. Okay. So as you can imagine, it's not going to really make that much of a difference in the end quality of the picture because it's just changing the first bit of every byte in the image and adding data in that, hiding data in there. So what you're going to do first is, let me go back to the page.